Hi students, welcome to chemistry classes. In previous class, we have studied uh, two colligative properties. One is relative lowering of vapor pressure and elevation of boiling point. Okay. And now in this class, we are going to start the third colligative property, that is depression in freezing points. Okay. Depression in freezing point. It is the third colligative property. Okay, colligative property means those properties which depends only on the number of solid particles, not the nature of solid particles. Okay, so student, depression in freezing point, it is a third colligative property. Here depression means reduce. Okay, then freezing point means, so freezing point means what? So freezing point means vapor pressure of liquid and its solid becomes equal to each other at a constant temperature. Okay, means for example you can take water and ice. Okay, water and ice, they should become equal to each other, means vapor pressure of water and vapor pressure of ice becomes equal to each other at a constant temperature is called a freezing point. Okay, so here student, freezing point means the constant temperature at which vapor pressure of liquid and its solid, vapor pressure of liquid and its solid becomes equal to each other is called a freezing point. Okay, is called freezing point. So student, you can take an example, water and ice. Vapor pressure of water, example, vapor pressure of water, it's become equal to the vapor pressure of ice. Okay, vapor pressure of water is equal to the, means it becomes equal to the vapor pressure of ice at a constant temperature. Okay, it is called a freezing point. And students, the depression in freezing point. Okay, depression in freezing point, addition of non-volatile solute to a solvent decreases its vapor pressure and also its freezing point. Okay, so here student, depression in freezing point means addition of non-volatile solute to a solvent, decreases its vapor pressure, and freezing point. So by addition of non-volatile solute to the solvent, its vapor pressure and freezing point both are decreases. Okay, it is called depression in freezing point. Okay, this is called depression in freezing point. Okay student, this is the definition of depression in freezing point. Addition of non-volatile solute to a solvent decreases its vapor pressure and decreases its freezing point. This is called a depression in freezing point. And graphically you can represent like this. So this is x-axis and y-axis. So x-axis means vapor pressure, and y-axis temperature, okay. If you increase the temperature, the vapor pressure of a solvent increases like this, okay. Vapor pressure of solvent is increases, okay. And temperature, if you increase the temperature, vapor pressure of solution, it is also increases like this, okay. This curve indicates the solution, vapor pressure of solution, and this curve indicates the vapor pressure of a solvent, okay. And this one, the difference between the vapor pressure curve curves between solvent and a solution, it is called delta TF. Okay, delta TF means depression in freezing point, and this curve TS, and this one TF naught, okay. This one TS and TF naught. TS means freezing point of a solution, and TF naught means freezing point of a solvent, okay. I will write here delta TF is equal to TF naught minus TS, okay. Delta TF is equal to TF naught minus TS. Here delta TF means depression in freezing point, depression in freezing point, and TF naught means freezing point of solvent, and TS means freezing point of solution, So delta TF is equal to TF naught minus TS, depression and freezing point of solvent, freezing point of a solution, okay. And student, this is depression and freezing point is a colligative property, and depression and freezing point for dilute solution is directly proportional to molar concentration of the solution. It is like a elevation of boiling point, okay. Let us see. So student, depression of freezing point for a dilute solution. So here depression of freezing point for a dilute solution, it is directly proportional to molar concentration of the solution. It is directly proportional to molar concentration of the solution. It is directly proportional to molar concentration of the solution. Molar concentration of the solution means here that is delta TF is directly proportional to M, okay. Or you can write delta TF, just remove this directly proportional to sign, it's become equal to KFM. Delta TF is equal to KFM, okay student. Here KF, where KF means molar depression constant, molar depression constant, or it is also called cryoscopic constant, okay student. Delta TF is equal to KF into M. So here KF means molar depression constant or cryoscopic constant. So student, here M molar concentration, M is equal to KF into W2 into 1000 divided by M2 into W1, okay. You can write like this also. M means KF into W2 into 1000 divided by M2 into W1. Here W2 means mass of a solute in gram. W2 means here W2 means mass of solute in a gram, and W1 means mass of solvent in gram, and M2 means molar mass of solute. Okay, or you can, here I will write it, where W2 means mass of solute in gram, mass of solute in gram, and W1 means mass of solvent in gram, and M2 means, here M2 means molar mass of solute, molar mass of solute. Okay, so this is the application of freezing point also. Okay, so student, depression of freezing point is directly proportional to molar concentration of the solution. Delta TF is directly proportional to M. This M indicates the molar concentration of solution. So here delta TF, just remove this directly proportional signs, and it here you can take a cryoscopic constant, that is Kf into M. So Kf means molar depression constant or a cryoscopic constant, and M you can represent like this: M is equal to Kf into W2 into 1000 divided by M2 into W1, where W2 means mass of solute in gram, and W1 means mass of solvent in a gram, and M2 means molar mass of a solute. Okay, means a known mass of solute W2 is dissolved in a known mass of solvent W1, and freezing point depression delta TF is determined experimentally. Okay, by knowing these values, Kf means cryoscopic constant, and molar mass of solute can be easily calculated. Okay, and students, and next last colligative property, that is osmotic pressure. Okay, here osmotic pressure means it is just a driving force of the process of osmosis. Okay, I will write here osmotic pressure means the driving force of osmosis process, the driving force of osmosis process, and it is denoted by pi, Okay, students, and what is meant by osmosis? Okay, so this is important, one marks question, osmosis. Okay, student, here osmosis means the flow of solvent molecule from a lower concentration to higher concentration through semi-permeable membrane is called osmosis, or you can say flow of solvent molecules, from dilute solution to concentrated solution, through semi-permeable membrane, membrane. Okay, this is one marks question. What is osmosis? Okay, the flow of solvent molecule from a dilute solution to a concentrated solution, through semi-permeable membrane is called osmosis. Okay, and here students, the application of osmotic pressure. Here osmotic pressure is used to determine the molar mass of proteins and polymers and other macromolecules. Okay, here applications of osmotic pressure. Application of osmotic pressure. The application of osmotic pressures are osmotic pressure are used to determine the molar mass of protein, molar mass of protein, molar mass of protein and polymers and other macromolecules okay. And one more student, that is reverse osmosis. Okay, reverse osmosis, it is just opposite to the osmosis. Reverse osmosis means here the phenomenon in which a pure solvent flow out of the solution through semi-permeable membrane. Okay, or you can say reverse osmosis occurs when a pressure larger than the osmotic pressure is applied to the solution side. Okay, reverse osmosis means the phenomenon in which pure solvent flows out of the solution through semi-permeable membrane. Semi-permeable membrane is called reverse osmosis. And application of reverse osmosis is reverse osmosis is used to purify the salination or saline water, or you can say it is used in reverse osmosis used in desalination of water. Desalination of seawater. Okay. This is the application of reverse osmosis. Okay. In this process, seawater is separated from the pure water by semi-permeable membrane. Okay. And student, next one is isotonic solutions. So here student, isotonic solutions means two solutions having a same osmotic pressure at a given temperature are called isotonic solutions. If two solutions having a same osmotic pressure at a constant temperature are called isotonic solution. There are three important conditions are there. First condition, that is 0.9% mass by volume NaCl solution is isotonic with the fluid inside the blood. This is called normal saline solution. And second condition, if these cells are placed in a solution of concentration higher than 0.9% NaCl solution. Okay, so here students, if these cells are placed in a solution of concentration higher than 0.9% NaCl solution, and cells would become shrink. Okay, so this type of solutions are called a hypertonic solution. And third one is, if these cells are placed in solutions is less than 0.9% NaCl, then water will flow into the cells, would swell, means it is a hypotonic solution. Okay students, simply isotonic solution means the osmotic pressure is same. Okay, two solution having same osmotic pressure. And next one, hypertonic solution means osmotic pressure is higher than the normal solution. Then here hypotonic means osmotic pressure is lower than the solutions. Okay, so this is about the two colligative properties. One is depression in freezing point and another one is osmotic pressure. Okay.